Oh, yeah. Now it's okay. Now it's working.
Is recording?
Recording in progress. Yes.
Okay.
Mhm.
Okay, I have to click here. Okay, guys. Okay, I will share my screen now. Do you see my screen?
Yes.
Yes.
Okay, good. So, okay, I think we will start with the document I sent you, just to have some order. Yes, let's start with this. No, let's start with the mail, because I wrote there some instructions, and you can see there more or less where to find the information. So any of you already check for the data, download something, or not yet?
I haven't. I didn't
I
manage
haven't
to
as well.
yet.
Yes.
Okay. So first you can go to this link here. I put all the data you took in the session, in the lab. Everything separated in your own folders. Let's see. Oh, what is it? Why is not? Okay, this is correct. So here you have your own folder with the data you took. And I put in this folder called, let me see if it was, no, it's not this one. In the script example analysis, here there's some codes. You will use here the scripts that have the extension PLT, which is like plot, I assume. These files will run with the gnuplot in Windows. Well, I just assume that most of you have Windows, but this can run also in Mac or in Linux. I think Linux and Mac is more like natural for this, but also works correctly on Windows. So you both have Windows, or some other OS?
I think we all have Windows except for Olha, since she has Mac OS.
Ah,
I
okay.
think so.
Okay, so maybe at the end, one of you can like exercise this in case I'm missing something, but it's quite easy. So here there's three. There are there are three scripts. You can download this, and you can copy to your own folder. Here I have some folders, some data, and the data you will analyze is this one called PMT charge. This PMT charge file, I will open it. So in this PMT charge, there is a list of every entry in the list is the charge, the integrated charge from the signals that we saw in the session in the laboratory. So here we record, for example, this is first entry is 0.5 or 5 picocoulombs, and -4, -1, 1, and so on. So with this data, you will fill the histogram. So it's just simply a text file with all the charge of the practice you did. And this one you will analyze first. Let me see. Da, 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 da. Yes, with this program, I will highlight this. I don't remember. I think I already sent you this. Okay, with this program called no, it's this one. Gnuplot histogram, I think. No. Yes, it's this one, yes. Gnuplot histogram that will generate the first histogram with the data, with this data from the PMT charge file. Is this one here, and this one will generate another file I think it's called hist dot dat. We will see this in detail. I will just explain roughly first. And this hist.dat will create a file with the entries of. Oh, sorry. Okay, I will save this and open it. Okay. Okay, this is what we will create this file, which has several columns here, and first in the first column, if you see here is the like the position of the x-axis, which is the bin, the first bin, which is in the middle of the bin is in the minus 5.3. And this one have just one entry. The second one is in the 5.33. It was has another entry, and you see here that the number of entries is increasing, and then it's lowering. So this represents the histogram that is processed by the other program, which is this one here. So you will run first this one. It will generate this histogram data. And then the second program will plot the histogram, and also will fit some Gaussian functions to the two peaks. We will see here in the document. So we can go to the document. Oh no. Let's go to the mail. Oh no, I think it's the same explaining. Okay, we will go to the document first. Here. Okay. Okay, for you to install the program, you can go to this link here. You can download, you will see this web page and download this program, the latest version. You will get an exe file. You use a double click here and it will install. You can create the shortcut in the desktop. Then you open there the gnuplot program, and you will see something like that, this window. So to work with this, you can either write commands here in the terminal. You will find some kind of a terminal like this, for example, and and you can put commands here, or you can also open the script files using this button here. So the better I think will be just to open the programs and run it. And also the programs, you can open them separately in some text editor, in any text editor, and modify. So we can open one of them. Give me a second. Is here. Let's say we use the first program. First application. Okay. This is the first script. So here I will also add some comments. This will be updated anyhow. Okay. Okay, this program first have some parameters for the histogram we want to create. You can modify as you want these numbers here. So this is parameters for the histogram. And in the first one, you have the number of intervals, or the number of bins you will have in the histogram you will create. Then the maximum number on the x-axis, and then the minimum number of the x-axis here. Then this thing calculate the width of each bin depending of the number of bins you have here, and the range you select. This maximum minimum is the range, so you create the size of the bin practically here. And then we create this Actually, this I don't know is this is to create the histogram. So this is the parameter. Well, this is just to create the histogram. I'm not so sure how it works, but we can create the histogram with this function. Then we create here the output file for the histogram that we will have. So we will have an output file which is a image, a PNG image with the histogram we will create, and we set the ranges for the histogram from minimum to maximum, and here from 0 to wherever to infinity, let's say. So to the maximum number we can go from depending on the number of entries we will have from our measurement. So then we create some. Oh, sorry. So then we create here. This is to set the scales and some parameters from the plot. For example, the style of how the histogram will be plotted. We are telling that is plotting with some boxes, and the labels on the x-axis, the labels on the y-axis here. And here we are opening the file, which is pmt_charge.dat. But let me see, I'm not sure. The files, yes. Yes, actually we'll open this one here because we have opening this folder and then opening this PMT charge file. And this one here, this plot, this file, then use this, u means use the function histogram, and this means that the first column from this file will be used for fill the histogram, and this width basically is this bin, is the width of the bin, and this is the style how the histogram will be plotted. So it will create boxes to have this boxes style. It will use some green style and with no title in the top. Sorry. And then this supposed to create some log scale in the y-axis, but actually I haven't been able to run it properly, and it's not plotted in log scale. I'm not sure why. I tried to do it, but it's not working. But well, it's there. If you manage, you can tell me how how you did it. But I didn't have too much time to check like what was the error, but this is not working, but it's supposed to be working. So then we have as output this image that I told you before, from PNG, a PNG file, but also we will have this histogram file, which will create a file with the histogram that I showed you before with the several columns. The first column is the x-axis for the bin, and in the second column is the value of numbers of entries which correspond to this bin. So and then we have to plot again the data. We use practically the same command here, and we close like this table that is created here. So this is the first program, and we can run it. Well, for you which are using Windows, I told you, well, just click this button, and then you open this file. This will be the file. Double click here, or just select and do open, and it will run the script, which is actually this script. But if you are on Linux or Mac, you have to use the terminal. So I will go to the one has to go to the folder where you are working. So let me go to my folder. No. Then 13. Then is script. Okay, so okay. Okay, so here we have we will run this one, this program here. So so in case you're using the terminal, you type gnuplot, and then the name of the no, then -c, and the name of the script you will run. So this play in this case gnuplot histogram.plt. So we click enter, and well, this means that there's no there is no message, but this one that means that run properly, no errors, and we can open we can have a look for the output, which is the histo.dat and the plot. So we can go. Actually, I will delete and you will see how it's created. So I will delete this, move to do, doesn't exist anymore. And then in these plots, I will delete everything as well. Okay, I will put this here and this here. Okay, so I will run again because I delete everything. And okay, I'm running, and this thing appear here, as you see. So we can open it, and you see here the same structure that we saw in the lab. We have a very big peak here, which is the noise, and some other peak that is not so clear here. Actually, this is weird. Okay, I see. Okay, this part here should be another kind of a Gaussian shape, which have the single photon information. So this is the single peak, and then this one is the peak for the single photon. And okay, let me see, because there's a problem here with this axis that is not plotting correctly. So let me check. So I close this, delete. Yes.
Olga has connected.
Sorry.
Oh, yeah. Yeah, hi.
Hello. How are you?
Sorry,
Didn't you
something
mention
wrong.
that you had troubles with the setting it to log scale? So
Mhm.
it's not in the log scale.
Yes, it's not in the low scales. For
so-
some reason, I
Okay.
didn't manage to do it. I don't know. I'm not sure what is the problem. Okay, so here feel solid also, but also there is a program offset graph max box weighted point. It should be some tick. Tick. This one.
What are you looking for?
Yes, I think X tick, it should be min max over 1. No, yes, because X tick is creating the. Okay, I will do it again and you will see. But let me see. I'm not sure if. So I run this. I create the histogram, and you see here in the horizontal axis is just -6 to 20, but there's no lines in the middle, like in the vertical, the frequency. So something in the script is not correct. But I think it should be this one. Is the okay? You have the minimum in the x in the x-axis, the maximum, but here is just one. I will put, I don't know, maybe let's say 50. Maybe it's too much, but let's see. We'll delete this one and move to bin. Let me see if it worked. Yes, but it's too much. You see, it's too much. So I will do 5 of 10. Not sure. You can play around with this and then set it. And okay, I see it's better. Okay, you see here now it's a bit better. And maybe even more. Let's say 20. Okay. Maybe no, it's still too much. 15. No, actually, I'm going instead to go from -6. I go from let's say -10 to 20, and I want let's say 30, and to have like full numbers here. So 30, and let's see. Okay. Okay, you see here we have from -10 to 20, and we have a tick every one number, every unit. So you can modify this as you prefer here. Okay. So okay, I think the only problem is remaining here is this set log scale, because as you see here, is this peak here is not so clear, but it's more, it's roughly visible there. So I think it's enough. And also it's created this file. So I will run again, I will delete it, and you will see how it's created. And move to bin and run. Let's run here. And what is created. And so you can see so it's created here the number and the number of entries, and the histogram this one is the histogram. It's a very short file. Well, in comparison with the original file, which is this one, which is super long. Is I don't know, like 42,000 of entries. Okay, that actually this is the 42,000, no, 42.5 thousand of measurements that we did in the lab for this file. So okay, so then okay, those files are created, and then there's another script to make the fit of the two Gaussians to get the results of where is the position of the noise and what is the position of the single photoelectron. And this one is the the program called gnuplot double Gauss fit. So I will open it. LD. And okay, this is the histogram. So again, this thing will save another plot with the histogram and the fits plotted there. And we have to create the functions, two functions that we will that we will fit to the distributions. One can be for the noise, and another one can be for the single photon peak. So here we simply create the function, the Gaussian function, with the parameters, which is A, which is the amplitude, the mean of the mean of the Gaussian, and also the sigma. And here, these parameters that we have here, for example, this 2000 minus 5 and 1 is like roughly the result that we could expect from our measurement. We put like previous some values that we could expect from the feed, just to make it faster or easier for the program to find the parameters of the feed. And then we use this fit function using the Gauss function, which is this one here, and we assign his data that we create previously, which is this file here. So this thing will open this histogram data, and then we'll feed this Gauss function that we define here. And this mean using, which will use the first column as the x-axis and the second column as the y-axis, and and this will use the parameters of the Gaussian, which is the A, the amplitude, the mean, and sigma, which are these three parameters, and it will fit the Gaussian in some region. In this case, we put certain region where we want to fit. So if we see the histogram, we see here that the first peak, this big one, is between maybe around 6 and 4 probably, or even 5.5 or 6.6, something like this. Is around 5. So we can set here this range. I will put something more closer here. Let's say 6.5 probably. I will fit here from 6.5 to 5.5. 5.5. No, up to 4. Up. Minus 5.5. Okay, and then a Gaussian will be fitted between these two numbers. And for the second Gaussian, here is more difficult to see, so we can check here maybe from 4 to, let's say, 1 probably. And then here I will put well, it's actually 3 minus 3. Well, I will leave it like this. From 3 to 6, maybe 6 is too much. I will put it to 0 probably. Oh, it's 3.6. No, 3.6 to 0. That's fine. So it's fine. From 3.6 to 0, it will fit some Gaussian here. And in this last line, we will plot the data. And also we are going to plot the two Gaussians. The first Gaussian, which is the one for the noise, or the baseline, or pedestal, also is called pedestal, this peak here. And the peak of the single photon, which is the Gaussian number 2, which is this one here. And it will for example, here we can change this LS is for the color of the line. We can change this number, and we will create different colors just to distinguish them when it's plotted. So we can run this one here. Gnuplot. Gnuplot. It's the gnuplot double Gauss .plt. And okay. Okay, here you see a bigger message, a longer message. So we have this list of these are the iterations that the program did to fit the to find the right parameters of the fit with the histogram. So this program is like setting some parameters to the A, to the mean, and also to the sigma. And then depending on the error is doing another iteration to correctly fit the histogram to the function. And at the end, when find the right fit, this will create the output, which is this one here. So here you will find the amplitude, which is practically the amplitude of the height of the Gaussian that is fitted here. Then the mean, which is the position in the x-axis, and the sigma, which is the width of the Gaussian. So you see here the parameters. You have the amplitude, the mean, which is minus 0.4, no, minus 4.66, somewhere here, more or less. And the sigma, which is 0.14. And in this second column, you find the error of the fit. So you find here plus minus 0.0096 and 0.0096 also for the sigma and mean, and the percentage which represent with respect to this number. So this is for the first fit. And for the second one, we have also here the parameter A2, mean 2, and sigma 2, which found that the mean is around -2 more or less, and this is the width. So it's the mean of the single photon is probably around here. And so and then you use these numbers here and here as the results, and you also have the errors that you can use to calculate the result from what is the charge produced by a single photon. I told you before in the lab, you have to subtract this number this number of the pedestal to this number here. And you will get the value with respect to the pedestal of the charge of the one photon. And I think that's it. No, you can see also the file. So let's go back. The plots. You can see the plot. Okay, we can go to the plot. Wait, this one. Okay, is this one. So this is the second plot that is created. You see here that is this blue the blue histogram here. Oh no, this blue line is the Gaussian of this fit of the pedestal, and you have another like green more or less. Well, you see actually here the colors is the fit to the single photon. So it's more or less it's reasonable. Yes. Someone talk or have questions? Okay, no.
No, I think it was by accident. Yeah.
Okay. Okay, so here you see that the two Gaussians are fitted here, more or less, looks reasonable. And also the histogram. You have the histogram in magenta, then in blue the first Gaussian, and in this green color the other Gaussian. So you have everything here. and then you can use this for presenting your results. And
Actually, I have a question.
yes,
About this graph. So you mentioned that we have to subtract the I forgot the pedestal or the tall one
it's pedestal.
pedestal
Uh-huh.
from this lower or
Yes.
other way around.
No, we actually subtract the pedestal from the single photon mean.
And then we get, what do we get?
You get the value of the charge of the well, the mean charge of one photon hitting the photon multiplier. Okay, actually, I would like to explain that. Probably it's good for you to know from where this is coming from. Not sure if I already explained you in detail, but okay. Well, I also touched in the email this link, so you can consult. This is like a manual from the this like a quick introduction to these PMTs. So you can go to this link, and in here you can read like maybe the first two chapters with the basic things of the photomultipliers. So I can go quickly and give you an overview. Okay, don't go too in deep in this. It's not necessary. Maybe in the first chapter you can just read more or less. But I think the second part is more important for this work. The second chapter, and you will see the basic function of the photomultiplier, how it working. So in principle, the photomultiplier, all of them are roughly the same. They function more or less the same in the same way. So we have some like crystal window with some a special material here that when the light is hit this window, an electron is released, and then it's accelerated to these plates that you see here. These plates are called dynodes. These are dynodes, as in here. So first the electron impact the first dynode, and then we have like let's say two electrons from this impact, and then these two electrons produce more electrons, and then an avalanche of electrons is created. So this is the electron multiplier with the dynodes. And then at the end, in the last dynode or anode, is also called anode, is collected the full charge created by the photon, which release an electron and is multiplied at the end. So and then we can see a big signal in the scope, and then in the digitizer that we use. So then we have, well, there are many different type of photomultipliers, but we don't need to go through this, I think. And yes, well, at the end we have let me see, we have the signal, and this signal I can write here annotate, draw. Okay, I can draw. Okay, at the end we have some signal similar to this, something like this. And what we did in the lab was to make integration in some time window, which practically what it does is like sum everything that is inside this signal. We have and then we have the integral, which represent the charge, the total charge of the signal. But we also integrate the signal, but also when we don't have signal, which is like it's a signal or an input with not with when we didn't detect any photon here. So we saw something like this, maybe some just noise. And the noise here is the pedestal. This part is called the pedestal, the integration of many inputs of this, and this is pedestal. Oh. Sorry. Yes. This pedestal. And this is the signal, the single photon signal. So and that is what you see here. So and actually the pedestal is just like a baseline. Is why you subtract to the from the signal here this pedestal, because this can be moved maybe to other place. We could even have this distribution around 10 or around 20, but the single photon is relative to the noise, which is the pedestal. So we subtract and we have the relative position from the single photon to the position of the pedestal here. So and it's more or less clear, Olga?
Yeah, I now see where it comes from. Yeah.
Okay, that's good. And then well, I have to stop. Okay, now it's normal. And then we have here, I also attach, I don't remember if I send you sometime some I don't remember how to delete everything here. No, okay, yes, I attach here uh, I attach here these papers. You can also check more or less. You don't need to understand everything because it's like it's too much, but just for you to have an idea how it looks from from real life, this type of studies.
I had like a question. You have sent us all the data that we received that day,
Yes. It's in
but like
the
I was checking my email, but I couldn't. I wasn't able to find those data.
I redirected this email to you like a minute or two ago. Yes, you weren't included in the like. So
Okay.
I resent you.
Okay.
Check.
Yeah. Like Ilya resend it to my email. All right.
okay. Yes, you open this link and you have your folder with your name. Okay. So for example, this is one example of this. Okay, you don't need to check everything. Maybe you can have a look here. Well, read the introduction and maybe a bit of this second chapter of the model. But what I want you to see here, it's a little bit of the theory. What does it mean? This part of the single photon. Why is what is the application for this? And a little bit of theory, but also, for example, put attention on the scheme. We have some scheme that is very similar that what we had in the lab. So we have instead of a laser, they use a LED. We have this ADC which make the integration, and some generator and some computer to acquire the data. And then they have this type of distribution with the peak of the single photon. but also it's possible to detect 2 photons, 3 photons, and several other things. This is a much more like more detailed study, but for the practice we don't need that. But we have this pedestal. You see, we have this pedestal also. We have the peaks from this 1 photon, 2 photons, and so on. Something very similar. Also with different configuration, with more light, with less light, and different stuff. And well, this is one of them. Let's check out the other one. Let's wait a little bit. It's taking too much. Or my internet is slow, I don't know. Okay, let's see the other. Well, it's a little bit slow. Okay, maybe I can go directly from here. So, okay. Okay, this is another one which is like characterization of one specific photomultiplier from one experiment. And you can have a look a little bit here on the data description, the data acquisition system, and a little bit of theory of how the PMT works. But they have more or less something similar as us. They have here the pedestal, the single photon electron region. This is a single photon, and here is multiple single photons, similar to the other one. So you can check here, and you can see more or less. This is more or less the work are you doing here. So, but this is more the detailed work. And this one here, let's see if it will open. If not, I will open. And this one, I think I showed you before this one, but practically is more or less the same. Actually, this is well explained about the PMTs and what is the single photon. You can have a look here, and we have something similar here. So we have again the pedestal, the single photon signal, but also the setup is quite similar as the one we use. We have the digitizer, some amplifier. If you remember, we use no, we didn't use amplifier, I think. But we use digitizer. We use laser, some laser here. Actually, this is the laser pulsar, which is the pulsar or the signal generator we use. Then the laser that we had. Then we have this. No, we don't have filter box, but we have attenuator from the laser, and then we have a PMT here in the dark box. So this is quite similar. And actually this is very similar that we did. We have this signal and the integration window and some signal here that is integrated. So this is quite well explained here. And also there's a kind of a study from the different voltage. If you remember, each of you took a different voltage, and this changed a little bit with the voltage. This position of the single photon. So you all of you will have a slightly different results. Well, it will depend also on the precision we will use, but we will have like a slightly different results. And I think that's it. And something else. So everything is more or less explained here. And anyhow, if you have any question, you can write me, and we can see sometime next year, or anytime if you write to my email. And I think that's it. Yeah, I think that's it. So, any of you have some questions or doubts, or if you try already and you have problems, you can even let me know and we can try to solve it.
So I
So
wanted to know that like when we graph the data, when we put the x and y values in the data, we're immediately gonna get the chart that you showed us at the first point.
Sorry, but what is the question? I didn't get the question.
When we are gonna like take the data and put it in a graph, like we are immediately gonna get the chart that you showed at first. Are we going to get the chart first?
Okay. Well, you wasn't here at the beginning, but the charge is already in some file in your folder.
Okay.
So there's a file, I think it's here. For example, let's go to yours. Okay, here you have this file, which is called PMT charge, and this is the charge. So there's just one column, and each entry is one measurement, and each measurement is the charge of this measurement.
So these are the y variables.
Yes. No, it's not
Okay.
quite variable. It's because you what we did is just start the laser and we measure some signal and we calculate the charge. And this is the charge. We just need one measurement, but we repeat this measurement thousands of times.
So like if I access the text file and if I want to plot the data, so how can I get the time and these are the charts. So this will
Yeah, yes.
definitely go in y-axis, but where is the time? Is there the time for
No.
x-axis?
It's not here. It's not here because that is to analyze. That is for analyze the what is it? The signal per signal, each signal. But you have to go to this data. You need another program to have a look all of this data. But we don't need it. I think it's it's not the scope of this, but actually that was done at some point with some program, and then we created this charge. So at the end, we just need the charge of each measurement. The time for this is not relevant, I think, unless maybe you can do another type of analysis, but I think it's not worth because the aim is just to for you to make this analysis and write the most important is to write a good report. So I think it's better for you
Okay.
to concentrate and write a good
So
report.
we are already like given all the components and we just have to put them together to write the report for it.
Yes,
Am I
yes,
right?
yes.
Okay.
Mhm. Olga, you
and
have
also I have a question.
yes.
Oh yeah. So all the graphs that we need to plot,
Mhm.
they're all in their folder in our folder, right? Like the um how to say it, like the number of graphs and the variables.
Mhm.
I'm just not sure how many graphs we have to plot.
Actually, at the end, just one. At the end, it's just this one.
This
But
one.
but you have a preliminary, but it will just help you in case you have problem for fitting, which is
Mhm.
let me see here. You have this one here, which is the first one. We doesn't have any fitting of the Gaussian. With
Mhm.
this and this is the fitting. So this one is the
Mhm.
like the preliminary. If the position of the single photon is maybe moved somewhere else, you can adjust the script to make the better your fit here. But this
Okay.
is like preliminary. You see here where are the distribution. If you need to modify, you modify the script, and then you will get at the end something like this. And this
Okay.
one is the only plot I think you will need.
Mhm. Okay.
Okay.
Like I wanted to know something like, do we given a template for writing the report? Like, have you added the template?
No, I didn't add it. I use but I don't remember if I send you already some overlay link. If not, I can send you, and you can
Yeah,
modify
yeah,
if
yeah.
you
I
want.
saw the overlift link, but
Yeah, yes, you
I
can.
haven't checked like if there is a template there or not. I'll check it.
No, I didn't make a template. I think you are free to choose any template.
Okay,
For
okay. Then we'll do it. We'll do it like the way
yeah,
we want.
the file I send you, you can use clone it and delete whatever you don't need there and put new stuff.
Okay.
And
Okay. So is there any example paper given to us in the links? Like you showed us a paper, but is it given to us in the link?
yes, well, I attached these papers. They are attached. You can download them from them.
Okay, okay. That's fine.
And what else? I was about to say something. Okay, yes, I remember. It's well, there's two things. One, the content of the report. It should be, I think I put it here or no? No, it's not here. This one. Yeah, yes. I think it's in one of these. I don't remember where I put it. Mhm. No, it's not here. There- Where is it? I forgot where I put the content for the report. It wasn't one of these presentation, but I don't remember exactly where. Processing, example. It's here. It's by free. No, not here. I saw it just before the class. I saw it, and then now I don't find it. No, no, the part two. No, I don't remember, guys. I will have a look and send you. Don't remember. Okay, but okay. Complete. Mm. Oh, yes, it's here. Oh my God, it was in the first slide. Okay, this I think we saw this sometime. Well, the report should have some theory. You can write some lines, some paragraph inspired on the files I sent you with the PMTs and the single photon papers. You will explain the experimental setup, how we did the measurement, put some pictures here and make some draws of the setup and things like that. Then you will write the results we get, have the data processing, which is practically what we did with the scripts. And then you have to put some discussion and conclusion. So you can there discuss what you understand of this all this experiment and make some comments at the end. So this is like the rough outline of the report. And the other thing is just I wanted to talk about the dates for everything. So let me make this bigger. So this is what I propose for you to have the reports and the dates for the exams. But if you think we want different dates, we can change it. This is no problem. So I think you can give me the homework in January, the first week. I think I'll be there. Then we can have the exam the next week. And the practice of the report, this I think they will take more time. It can be January 19. And then I will give you back with correction and comments to your reports, and then you can return back the practice with corrections on February 2. So that is my proposal. So you can take note of these dates and well, I'm still flexible, but this is just like the first proposal. And I think that's it. So you have questions or something or comments, you can let me know.
I think everything is clear.
Exam will be, they have some, how to say, concept of how the exam will look like?
The exam, I will take from the homework, some problems.
Okay.
Few problems from the homework. So if you do a homework and you understood, practically the exam is solved.
Okay, perfect.
Yes.
Now I had a question, like all the problems that are given are also like the rules are given in the slide, all of them?
Which rules? I don't understand what you mean.
Like the problems require some rules to apply on them so that we can write the things correctly, or maybe make some changes to the measurement or make their graph. So are they all given in the slides that we studied, or there are some external resource that we have to also study for solving the all of the homeworks?
No, practically everything is in the book. So you will need to read the sections which correspond to the problems, and I think that's it. I don't think that you need more resources. Of course, you can search on internet or wherever, but most of the information it's in the book already, so you don't need much more. But no, I think it'll be the same from the homework and the exam. I think I will not change much, I think. So, but because actually the most important part, and that I think that the part is more important is the report. So because there you can make details and use everything that we learn in the course. Okay, and more questions or that's it?
I think that's pretty much it.
That's it. Okay, so you stop share And stop recording.